So in today's class we are going to discuss about how to obtain a DFA. So we are given with certain conditions and the set of symbols which are going to be accepted by the DFA. Based on that we are going to construct the DFA. So now the condition which is given to us is the DFA should accept any number of A's followed by a string BA. So here compulsorily the string BA should be there and it can start with any number of A's. After that we should get BA in middle, then continued with we can have any number of A's and B's. So the possible strings which we are going to get here by the obtained DFA will be any number of A's, means it can start with any number of A's, then followed with BA, then after BA we can have any number of A's and B's combinations. So any number of A's followed with BA, then any number of A's and B's. So the possible strings might be like this also, or else A, then BA, then B can also be accepted. So how to design the DFA for this particular given criteria? So initially we are going to have a state called as Q0 state, which will be considered as the start state. So the short trick to build the proper DFA for the given condition is we should concentrate on the condition. So here the condition is BA. So the DFA should have BA here. So I will take compulsory transition for BA first. So I will write B transition from Q0 to Q1, then A transition from Q1 to Q2. Now it is said that the DFA which accepts any number of A's. So first it can have any number of A's. So I will make self loop for this Q0. So here it can take any number of A's from the Q0 state, then followed with it can have B and A. Now after BA string our DFA can accept any number of A's and B's. So here I will write it as A's and B's. So here this will be the matching DFA for the given condition. So I will make this Q2 as the final state. So this is the final DFA obtained for the given question. Now we are going to define the machine M for the obtained DFA. So here DFA, the machine DFA is nothing but it is a quantuple which is having capital Q, summation, delta, Q0 and A. So here Q is nothing but the set of states. The set of states which are obtained here is Q0, Q1 and Q2. So Q0, Q1 and Q2. Then summation, set of input symbols are the combinations of A's and B's. So this one. Next delta, we will show the delta with the transition table. So I will write it as Q0, Q1, then Q2. The possible strings are A's and B's. Then from the state Q0 for A input symbol, the machine will remain in the Q0 state only. So I will write Q0. Then from the state Q0 for the B input symbol, the machining is moving towards the Q1. So from state Q0 after taking B, the machine is moving towards Q1 state. Then from the Q1 state for the A input symbol, we are showing the transition to Q2. So I will write Q2 here. Then there is no transition from the Q1 state for the B input symbols, hence I will keep it as blank. Then for the Q2 for A input symbol, it is self loop only, so I will make it as Q2. Then again for the B also it is self loop for the Q2, so I will write Q2 only. but we are supposed to show the transition for all the possible input symbol from all the states. So here there is a dash, that is empty, there is no transition from the state Q1 for the B input symbol. So there is no transition from the state Q1 for the B input symbol. So hence I will take this Q1 to the reject state called as Q3. I will introduce one new state called as Q3, and I will show the transition from this Q1 to Q3 for the B input symbol. So as we have seen in the previous lectures that the DFA should have all the possible transitions for all the input symbols from all the states. So here for Q0 we are having one transition for A and one transition for B, and from the state Q1 we are having one transition for A and another one transition for B. Also from the Q2 state we are showing A's and B's transition with the self loop here. So therefore it is mandatory in DFA that we are supposed to show the transition for all the possible input symbols. So here Q3 became the dead state. It is defined as the dead state or the reject state. It is being recognized as dead state or rejected state. Why we are calling this Q3 as reject state? Because if machine enters into this Q3, then it further can't move towards the final state. So the machine will halt here only. And as we are designing the DFA, we are supposed to show the possible A's and B transition even for this dead state also. So I will show the self loop for this dead state called as Q3 A comma B, and I am supposed to show this transition in this, that is Q3. For A it is remaining in Q3 only, and for B also it is remaining in this Q3 only. And one more tuple is Q0. Q0 is nothing but the start state. In our DFA, Q0 is defined with this Q0 is the start symbol. So here in our obtained DFA, Q0 is represented with this Q0 state only. And A is the set of final state. Here only one final state, that is Q2. So the final DFA will be this one. So now we'll see about the second example. So here the condition given to us is we are supposed to obtain a DFA for the strings A's and B's where the string should always start with the AB. The string should always start with the AB. So here the possible set of strings will be A, B, then followed with A, B, A, B, A, B, 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 and so on. And A, B, A also. Then A, B, B, A, B. Then A, B, A, B, A, B, B, and so on. So we can observe here for the given string, all the strings are starting with the AB only. All the strings are starting with the AB only. So it should accept these kinds of languages or these kinds of strings. Okay. So now I will again start with the state called as Q0 state. So we will make this as a Q0 state. So as I have told just now that we will concentrate on the condition first. So here the given condition for us is it should start with AB, right? So I will make the transition for A because we should compulsorily get that A followed with the B. So the string should compulsorily start with A and B. So I will make this transition AB. So starting with AB. The string should start with AB. Now if what happens, B comes in the Q0 state only. Okay, then I will introduce one reject state called as Q3, and I will make, if B comes to the Q0, I will make the machine to move to this Q3 state. Okay, so this Q3 will be acting like a reject state. Okay, for all the unrequired situations, we will make all those transitions to this dead state. So I don't want the string to start with B, therefore I will make the machine, if B comes, it should move to this reject state. If A comes, then it will go to this Q1 state. Then from the Q1 it should compulsorily take with the B. And what happens now? I have shown the transition for A and B because we are defining DFA here. So if A comes, there is a transition. If B comes, there is a transition. Then what about from Q1 state? If B comes, it will go to this Q2 state. If A comes, then again I will make the machine to come to this reject state. Why? Because we know that the machine should start with AB only. So here if I show self loop here, means if I show self loop here, then for this A transition, then the string, there will be the possibility of starting up with the string A, B. So because of that I am not showing loop for this A here. So I will just divert that transition to this dead state. Then I will make this Q2 as the final state, and I will show the transitions for all the next A's and B's possibilities. So here we can match the string. So if A comes, the Q0 will enter into Q1, then next will be B, then again from the Q1 state the machine will move to the Q2, then again for A it will take self loop, then again for the next A, then again it will take for the loop, and it will remain in the Q2, which is the final state. So now the machine definition will be Q summation delta Q0 A. So here Q is nothing but the set of states. The set of states are Q0, Q1, Q2, and also we will include the reject state here. Then summation, which is nothing but the possible symbols which are taking here. So they are the combinations of A's and B's. So summation is equal to A comma B. Then delta transition. So I will show Q0, Q1, Q2 and Q3. Then for the symbol A's and B's, where it will move. So from the state Q0, if it takes A, then it will move to this Q1 state. Then for B, it will go to this reject state called as Q3. Then again from the Q1, for A input symbol, it will go to this Q3 dead state. Then from the Q1 B, it will go to this Q2 state. Then from the Q2, for both A and B combination, it is remaining in the same state, that is Q2. Then for the Q3, we are supposed to show the transition. So I will make the machine to halt there itself. So for the Q3 also, it will remain in the Q3 state only. So here this is our start state and Q2 is our final state. And Q0, the set of Q0 is the set of start state. Here the start state is Q0 itself. Then A is the set of final state. In this final state is Q2. Now we may be asked to parse some set of strings for this obtained DFA. So sometimes the question may be asked to you as show the transition or the parsing procedure, one for the acceptance of the string, one for the rejection of the string. So let us take one acceptance possibility. So I will take this. You can try with others also, there is no issue. So if I take A, B, A as a string, then our machine will start with Q0. So from the Q0, if machine takes A, then the machine will move to this Q1 state. So it will come to this Q1 state. Then we are done with this A. Now is B. From the Q1 state, if B comes, then the machine will move to this Q2 state. So for this B, from the state Q1, it will parse this B symbol, then it will move to this Q2 state. Then from this Q2, then again this A will be parsed. Then from the state Q2, there is a self loop for A's and B's. So for this A, it will remain in the Q2 state only. Then from this Q2 state, again one more A is there. For that, again the machine will reside in the Q2 state only. So the last state where we are remaining should be the final state. So here Q2 is the final state. Hence the given string is accepted. Hence the given string is accepted. Then we'll go with some non-acceptance or the rejection of the possibilities of the strings. So that can be, so here the condition is it should start with AB. So I will take the example of BA. Here the string is starting with the BA, but the given condition is it should start with AB. So let us check whether the machine will, our obtained machine DFA will parse this or not. Now as we know that it will start with the Q0 state. Then initially the B symbol, this first symbol will be parsed. Then the machine will go or enter into this Q3. It will enter into this Q3. Next symbol is A. So A will be parsed from this Q3 state. So here Q3 A will be parsed. Then again it will remain in this Q3 only. Then again this B symbol. Then from the Q3 state it will parse for this B, and again it will take a self loop and it will remain in this Q3 only. Then again from this Q3 state, this last symbol A. So from this Q3 state, if A symbol is passed, then again it will remain in this Q3 only. So Q3. Now the final state which we are in currently is the dead state or rejection state. Dead state or reject state. Therefore the given string is rejected. So now we'll see one more problem. So where it is given to us that draw a DFA to accept strings of zeros and ones. Here the condition is the string should ending with the string 0, 1, 1. So here the string should end with 0, 1, 1. So the question might be asked to you in this format, or the question might be asked to you that draw a DFA or obtain a DFA for the language L is equal to like this. You may ask it with this also, or else the language can be further simplified like this also. So if it's asked with these three of any one, then you can answer for this same solution which we are going to discuss now. Okay. So here the condition is the string should compulsorily end with 0, 1, 1. So the possible strings can be, it can start with any combinations of zeros or ones, right? Any combination of 0 or 1. We are mentioning star, and here power n is nothing but n is greater than or equal to 0. So both are same here, both are same. So now I can have any number of 0 or any kinds of ones or any possibilities of 0, 1, 1, 1 like that, but compulsorily it should end with this 0, 1, 1. Now, so like this I can have, or I can end with this. Here also it is ending with 0, 1, 1. So like this we are going, now we'll see the DFA, or now we'll obtain a DFA. So we'll start with the start state called as Q0. Okay, and it is not mandatory always that we should start with the Q0 only. You can take any capital letters or any combinations of capital letters alphabets. Okay, so now we'll start with this Q0. And as I told you that compulsorily first try to design for the condition. So here condition is it should compulsorily end with 0 1 1. So I will make my machine to end with 0 1 1. So here 1 for 0, then again for 1, then again one more 1 I should get, one more 1. So here it should end with 0 1 1. So I will make this Q3 as my final state. But there is a condition that it can start with any number of zeros or ones, right? Any number of zeros or ones. So here the machine may take or the machine may start with any number of ones. So I will show the transition for 1 to this Q0 with the self loop, because it is not restricted that from where to it should start, or with what kind of combinations of zeros or ones it should start with. The condition is not given like that. The condition is how it should end with. So hence we will not concentrate on how it can start. So it can start with any number of ones, right? The only condition given to us is it should end with 0 1 1. So if I keep loop here for this Q0, then there will be no objection. Then we are supposed to show the transition for this Q1. So as we know that we are obtaining a DFA, right? So here we have shown the summation set for this question is 0 and 1. So from this Q0 I have shown the transition for this 0 and I have shown the transition for 1. Now I have shown the transition for this Q1 for 1. Now I am supposed to show the transition for this 0. Now if I show self loop here, then will there be any mistake? Just check. It can start with 1, it can start with 0. If it go with this loop also, then there will be no problem, because again it is ending with this 0 1 1. See, if the combination goes like this 1 1 1 or any number of ones, 0 0 1 1. So if 0, then this 0, then 1 1, then also our string is ending with 0 1 1, which is matching our constraint here. Now I am supposed to show the transition for this Q2. So as I have shown the transition for this 1 from this Q2 state, now I wanted to show the transition for 0. So here if I take this 0 with the self loop, then there will be chance of error, because the machine may end with 0 0 1 0 1. So if I write 0 here, then the machine may take the possibilities of 1 0 1. It may end with 1 0 1. So which will fail our given criteria. So because of that, I will not show the transition with self loop for this Q2 state. Okay. Instead of that, what I will do, let us check. If I take the 0 transition backwards to this Q1 state, then what will happen? If I show the transition from this Q2 to this Q1 for this 0 transition, then the machine may end with 0 1 1 0 1 1. So there is no issue, it is satisfying the given criteria. Now we are done with this Q2. Then what about this Q3? See, I can't show self loop as in the previous problems, because if I show self loop here, then the machine may end with any combinations of zeros and ones, so which will fail the given condition. So therefore I will show the 0, or I will move the 0 transition from this Q3 to this Q1 only. Why? Because if the machine gets back with this 0 to this Q1, then again the machine will further continue with this 1 1. So hence the given condition will not further fail. Then what about 1 transition from this Q3? If I take 1 here, then there is a possibility of ending with 1 1 1 1. Only 1 1 1 1 combinations. So hence I can't take the 1 combination or 1 transition from Q3 to Q2. I can't take this transition. Then if I go with one combination or one transition from this Q3 to this Q1 also, then again the machine may wind up with 1, 1, 1. So we should not make the machine to work wrongly. So we should restrict the machine to work in a required manner itself. So therefore I will not take the one transition from this Q3 to Q1 as well. I don't take this also. Then we can go with this Q3 to Q0. Sorry, Q3 to Q0 for one input symbol. For one input symbol. So now the condition will not further fail, because if 1 comes here, then again the machine can end with 0, 1, 1. If the machine goes for this 0 from Q3 to Q1, then again 0, 1, 1. So therefore the condition will not further fail. And here you can observe that there is no reject state being introduced, because we are having certain possibilities where we can divert the machine back from the start state to the end state with the given condition. So therefore this is the final answer for this particular given language. And we know that how to write a grammar, that is machine m is equal to q comma summation comma delta q0 and a. So now q is a set of states q0, q1, q2 and q3. Then summation is nothing but input symbol zeros and ones. Then delta, so you only try with the delta and you self solve this delta table by seeing this given DFA. Then I will show the other transitions, that is Q0, which is nothing but the start state. Here Q0 is the start state for the obtained DFA. Then A is the final state. So here final state is Q3. So I will write Q3 as the final state.